This is the Edexcel June 2025 Practice Paper 3. Question 1. The height of a building is 310 meters, correct to the nearest meter. Complete the error interval for the height of the building. So it's an error intervals question. It's 310 to the nearest meter. So the one up is 311. The one down is 309. And in order to round to 310, it has to be between these two midpoints. So between 309.5 and 310.5 meters. Question 2, we've got a Venn diagram. The entire set, so all of the numbers, are odd numbers less than 30. A is 1, 5, 7, 23 and 29. B is 7, 11, 15 and 29. And C is 7, 15, 17, 19, 25 and 27. So in the middle of all three circles, we want any number that's in all of them, and they all have a 7. So 7 goes in the middle. There's nothing else that all three of them have got. But A and B both have 29 in them. So in A and B is 29. And B and C both have a 15 in them. So 15 is in B and C. So we've got nothing else that's common. So we're just going to write in these numbers. So A has 1, 5 and 23. They're in only A, they're not in the others. So 1, 5 and 23 go in the A circle. 11 is in the B circle. And 17, 19, 25 and 27 are in the C circle. But remember, we need all the odd numbers less than 20. So we've got 1, we need 3, we've got 5, 7, we need 9, 11, we need 13, 15, we've got 17, we've got 19, we need a 21, we've got 23, 25, 27 and 29. So there should be 15 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is our Venn diagram. A number is chosen at random from the entire set of numbers. Find the probability that the number is a member of A and B, the intersection of A and B. The intersection of A and B has 2 numbers in it, and there are 15 numbers in total. So the chance of getting something in the intersection of A and B is 2/15. Question 3, use your calculator to work out. So it's just to type into the calculator question. So we've got square root button and a fraction button, and then it's tan 20. There's no degree symbol on the calculator. We just write the angle inside the brackets, plus sine 25 over tan 25 minus sine 20, and we get 2.515706,913. And write your answer correct to 2 decimal places. So the number after the second decimal place is a 5, so it rounds it up, 2.52. Question 4. We have potatoes in London and Dublin. In London, 1.25 kilograms of potatoes cost £1.45. In Dublin, 2 kilograms of potatoes cost €3.49. The exchange rate is £1 is 1.19 euros. In which city are potatoes better value for money? So we've got 2 things to change here. We need to change the money to make it the same, and we need to change the weights to make them the same. So we can either change the pounds into euros or the euros into pounds. It doesn't matter which way around we do it. So to change pounds to euros, we multiply by 1.19. To change euros to pounds, we divide by 1.19. I'm going to change them into pounds. So divide by 1.19. We get £2.93. So we know that potatoes in Dublin, it's 2 kilograms for £2.93. I'm going to make it 1 kilogram. So half the answer. 1 kilogram is £1.47. So that's the price in Dublin for 1 kilogram. In London, we know we get 1.25 kilograms for £1.45. So we can see that this is going to be better value for money. I'm going to make them 1 kilogram though still. So if we divide by 1.25, we will get 1 kilogram. So 1.45 divided by 1.25 is £1.16. So we can get 1 kilogram for £1.16 in London. It's 1 kilogram for £1.47 in Dublin. So London is cheaper. Question 5. Here is a rectangle. All measurements are in centimeters. The perimeter is 57 centimeters. Find the area. So we know all of the lengths. So we can add them all up and make it equal to 57. And then we will find out what x is. Then we can find the area because we'll know the lengths. So 4x plus 5x plus 6 plus 4x plus 5x plus 6. So add the x's. 5 and 5 make 10. Plus 2 4s, that's 18 x's. Plus 6 equals 57. Take 12 away from both sides. So 18x must be equal to 45. And then divide both sides by 18. So x is 2.5. X is 2.5. So now we know what x is. We actually know all of the lengths. So 4 times 2.5. 4 2.5s make 10. And 5 2.5s plus 6. 5 2.5s plus 6 is 18.5. So we know it's 18.5 along the top. It's 10 down the side. So the area is just the base times the height. 10 18.5s. That will be 185 centimeters squared. Question 6. Change a speed of 900 kilometers per hour to meters per second. So if we can go 900 kilometers in an hour, that is 900,000 meters in 1 hour. And each hour is 60 minutes. So if we divide by 60, we can find out how far we go in 1 minute. So 900,000 over 60 is 15,000. So that's 15,000 meters in 1 minute, which is the same as 60 seconds. So if we divide by 60 again, divide by 60, that's 250 meters. in 1 second. 250 meters per second. Question 7. Here is a right-angled triangle. Work out the value of x. So we've got a Pythagoras question. We've got all three lengths. It's a squared plus b squared equals c squared. The two short sides squared added together equals the long side squared. So we have 3.5 squared plus x squared equals 12.5 squared. Take away 3.5 squared from both sides. Type it into the calculator. So 12.5 squared. Take away 3.5 squared is 144. So x squared is 144. So x is the square root of 144, which is 12. Question 8. Gary recorded how many goals 10 football teams scored. He also recorded how many they conceded. We've got a scatter graph. And what type of correlation does it show? So as the goals conceded goes up, the goals scored goes down. That's a negative correlation. Negative correlation. Part B, another team has scored 44 goals. Estimate the number of goals this team has conceded. So we need to draw a line of best fit on our scatter graph. So it's a line that best represents this data. We want to minimize the distance from the points to the line. So we want roughly the same number of points on both sides. The shortest distance possible from the line to the points. Something like that. And the other team have scored 44. How many did they concede? So we want to go 44, which is here along to the line. And down. So I've got somewhere between 40 and 41 here. I'm going to go for 41. I think it's slightly closer to 41. But as long as you use your line of best fit, you'll be absolutely fine. So the line of best fit has to have roughly the same number of points on both sides. And you were trying to minimize the distances from the points to the line. Question 9. Here we are estimating the mean. Adam is measuring the heights of his tomato plants. He wants to estimate the mean height. So we've got 7 plants between 140 and 150. We don't know the heights of those plants. So we're going to estimate those 7 plants to all be the middle of 140 and 150, which is 145. We're going to say all of these 10 plants are 155 centimeters tall. These 15 are all 165. These 19 are all 175. And these 9 are all 190 centimeters. So we've got 7 plants, which are all 145. So we're going to add those up. And they add up to 1,015 centimeters. 10 155s will be 1,550 centimeters. 15 165s will be 2,475. 19 175s will be 3,325. And 9 190s will be 1,710 centimeters. So we want to add up all of these now. So that will be the total height of all of the plants, or our estimate for the total height of all the plants. So let's have them all added together. And we get 10,075. Now we want to divide by how many plants there are. How many plants are there? It doesn't actually tell us, but we know there were 7 and 10 and 15 and 19 and 9. So if we add those up, there are 60 plants. So we add them all up, divide by how many, and we get 167.9. 167.9 to one decimal place, centimeters. Part B, explain why your answer to part A is an estimate. That's because we didn't know the heights of the plants. We used the midpoint instead. So we didn't know the actual heights of each plant. We just knew that these 7 were all somewhere between 140 and 150. So we said they're all 145. So we used midpoints, not the actual height of each plant. Question 10. The diagram shows a cuboid. The cuboid has a height of 3 meters. Its volume is 21 meters cubed. And then we're told pressure is 25. Work out the force. So we don't know the area. The area of the base is what we need for the pressure calculation. And we know that we've got the volume and the height, so we can work out the area, because volume is the area of the cross-section times the height. So the volume is 21. We don't know the area, but area times 3 makes 21. So the area must be 7. So then we can put it into the pressure equals force over area formula. So pressure, which is 25, equals the force that we're working out, divided by the area, which is 7. We want force by itself. To get rid of a divide by 7, we multiply by 7. So the force is going to be 25 times 7, which is 175 newtons. Question 11. Water flows through each of the hoses that fill a swimming pool at the same rate. It takes 3 hoses 6 hours to fill the pool. Work out how many hours it takes 2 hoses to fill 3/4 of the pool. So we've got an inverse proportion part of this question. So the more hoses we have, the less time it's going to take. So that's inverse proportion. 3 hoses take 6 hours. So 3 6s are 18 hours. So it would take 18 hours for 1 hose to fill the entire pool. We need 18 hours of hose work done to fill this swimming pool. We're going to have 2 hoses. So split that 18 hours between the 2 hoses. That means it's going to take 9 hours for 2 hoses to fill the pool. But we don't want to fill it. We only want to fill 3/4 of it. So it's just going to take 3/4 of 9 hours. 3/4 of 9 hours. which is 3/4 times 9. Whenever we have of, that's the same as times. So 3/4 times 9, 6.75 hours. Question 12, simplify fully. So we've got 16x to the power of 4 over 9y to the power of 10 to the power of minus a half. The minus is going to flip over our fraction. So if we just flip it over, the minus is gone. The half is a square root. So we're just going to square root the top and square root the bottom. What multiplies by itself to make 9y to the power of 10? So 3 times 3 makes 9. And y to the power of 5 times y to the power of 5 makes y to the power of 10. 4 times 4 makes 16. And x squared times x squared makes x to the power of 4. Question 13. Omar buys a car for £12,500. The value of the car depreciates by some percentage each year. At the end of 3 years, the car is worth £6,968. Work out the value of X. By what percent does it go down each year for it to be worth this after 3 years? So we start with 12,500. We times it by something 3 times, and we end up with the car being worth £6,968. So let's work out what this multiplier is, and then from that we'll be able to see what the percentage we're reducing it by each year is. So we're going to do 6,968, and then we're going to divide it by 12,500, which is 0.55744. 0.55744. So that's y cubed. If we cube root, we will see what the multiplier is. So the cube root of the answer is 0.823. So that's what we multiply by each year. So what percentage are we taking off to multiply? When we multiply by 0.823, what percentage are we reducing it by? So if we do 1 minus 0.823, 1 minus the answer, and then times that by 100 to make it a percentage, we can see it's 17.7. 17.7%. So we're taking 17.7% off each year in order for the car to be reduced by that much. Question 14. Enlarge the shape by scale factor -2 with center of enlargement at the origin. So we're going to take a point. The distance from, or the movement from the origin to that point is back to, down to, left to, down to. If we multiply that by -2, negative times the negatives are positive, so it would be right 4 up 4. Another point, if we go back 5 down 2, and we times that by -2, we'll be going forwards 10, up 4. If we have back 3 down 4, and we times it by -2, we're going forward 6, up 8. And back 6 down 4, times negative 2 is forwards 12, up 8. So our new shape is here. And if we connect, so if we go through the origin, we should be able to join up each point with its new point. And we can. Question 15, make x the subject of the formula. So make it x equals. Let's get rid of the fraction first. So times both sides by x plus 2. So a times x plus 2 equals x plus 4. Expand the bracket. So ax plus 2a equals x plus 4. We want the x's on the same side and everything else on the other side. So there's no right or wrong way of doing this. I'm going to take x away from both sides and take 2a away from both sides. If you take ax away from both sides and 4 away from both sides, that's absolutely fine as well. So I'm going to take x away from both sides. And I'm also going to take 2a away from both sides. If you have to do that in 2 steps, that's no problem. Now my x's are on the same side. I want only one x, not 2 terms of x's in. So I'm going to have to factorize it. So x times a minus 1 is equal to 4 minus 2a. Now I've only got one x. It's multiplied by a minus 1 at the moment. So to get x by itself, divide both sides by a minus 1. So x is equal to 4 minus 2a over a minus 1. You might also get 2a minus 4 over 1 minus a. That's the same. Cumulative frequency. So we've got the cumulative frequency table done for us in this question. So cumulative frequency is one where we add up as we go. So everything up to 150 is 7, up to 160 is 17, up to 170 is 32. In these ones, we are plotting the top point against the cumulative frequency. So it's 150 against 7. So in a cumulative frequency, its top point, because the midpoint's meaningless in this, 140 to 200 just means everything up to 200. Everything up to 190. 157, let's draw them on. 160, 17. 170, 32. 180, 51. 190, 57. And 260. We can join them up with a curve or with straight lines. I will use straight lines. It's a lot easier on the computer. And that is our cumulative frequency graph. Find an estimate for the median. So we've got 60 plants here. The median is going to be the middle one. That'll be the 30th. So 30 along to our line and down. So that's closest to 169. 169 centimeters. If we were asked for the interquartile range, we need to split it into quarters. So there are 60, so that'll be 15, and 45, then the difference between them. So let's just do that quickly. So 45, the upper quartile is at 177. The lower quartile, 158. So 177 minus 158, which is 19. So the interquartile range is 19. If we were asked how many plants have a height greater than 185 centimeters, we'll go to 185 centimeters up to the line and then read off the number of plants. So up to 185 centimeters, there are 54, or greater than 185 centimeters, there's that gap there. So 54 to 60 is 6 plants. So we could be asked any of these sorts of questions on a cumulative frequency graph. Question 17. OABC is a trapezium. O to A is 3A plus B. O to C is 5B. A to B is 2B. D is the point on O to B such that O to D to B is the ratio 3 to 2. So there are 5 parts for the whole journey. We've got 3/5 and 2/5. E is the point on B to C. B to E is 4 parts. E to C is 1 part. So again, 5 parts for the whole journey, 4/5 and 1/5. We need to work out the vector D to E. So we need to get from D to E. So we're going to go part of the journey, O to B, and then part of the journey, B to C. So we can say that D to E is 2/5 of O to B plus 4/5 of B to C. So we just need to work out what O to B is in terms of A and B, what B to C is in terms of A and B, and then put them into here. So O to B is going to be O to A plus A to B. So 3A plus B plus 2B. So we go up and along. 3A plus B plus 2B is 3A's and 3B's. B to C, we're going to have to go the long way round. So we're going to have to go the whole way round there. So it's going to be minus 2B minus 3A plus B minus all of 3A plus B, and then plus the 5B. So it's minus 2B minus 3A and minus B plus 5B. So minus 2 minus 1 is minus 3 plus 5. That makes 2. So we've got 2B's and minus 3A's. So now we've got everything we need to work out D to E. So D to E is going to be 2/5 of O to B of this one plus 4/5 of B to C. So we need to expand and simplify now. So 2/5 times 3 is 6/5. 2/5 times 3 is 6/5 again. 4/5 times 2 is 8/5. And 4/5 times 3, negative 3 is negative 12/5. So add the A's and add the B's. We've got 14/5 B minus 6/5 a. And that is our answer. Question 18, write x cubed minus 4x over 3x minus 6 divided by x squared minus x over 5 in the form ax plus b over cx plus d, where a, b, c, and d are integers. So when we divide fractions, we can flip over the second fraction and change it to a times. So dividing by 2/3 is the same as timesing by 3/2. Let's do that first. So it's times 5 over x squared minus x. We're going to want to factorize everything we can, because then we will be able to simplify things. So let's have x times x squared minus 4 over 3 times x minus 2 times 5 over x times x minus 1. X squared minus 4 is the difference of two squares. We can factorize that again. It's the same as x plus 2 times x minus 2. And we can just simplify what we can. So if we divide top and bottom by x minus 2 and divide top and bottom by x, that leaves us with 5 times x plus 2 on the top and 3 times x minus 1 on the bottom. To get it into the right form that the question asks for, we just need to expand these brackets. So 5x plus 10 over 3x minus 3. Part B, express 3 over x minus 1 plus 2x over x minus 2 minus 2 as a single fraction in its simplest form. Whenever we want to add or take away fractions, we need to make the denominators the same. So we're going to make all of the denominators x minus 1 times x minus 2. And the 2 is a fraction as well. We'll start with 2 over 1, and we're going to make the denominator of that x minus 1 times x minus 2 as well. So 3, we need to times top and bottom by x minus 2 for the first fraction. So 3 times x minus 2 over x minus 1 times x minus 2. For the second fraction, top and bottom times by x minus 1. So 2x times x minus 1 over x minus 1 times x minus 2. And for the 2, we need to times top and bottom by x minus 1 times x minus 2. By x minus 1 and by x minus 2. So now all of the denominators are the same. We can make it into a single fraction. So we've got 3 times x minus 2 plus 2x times x minus 1 minus 2 times x minus 1 times x minus 2. So now it's just a case of expanding brackets. So we're going to have 3 times x is 3x. 3 times negative 2 is negative 6. 2x times x is 2x squared. 2x times negative 1 is minus 2x. I'm going to keep the negative 2 here, and I'm going to expand the double brackets. So x times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is a positive 2. Now I need to expand that again. So minus 2 times all of this. So we've got 3x minus 6 plus 2x squared minus 2x minus 2x squared plus 4x plus 2x minus 4, and that's still all over the same denominator. Now we're going to collect our like terms. So for the x squareds, I've got 2x squareds, take away 2x squareds, that's nothing. The x's, I've got 3, take away 2, so 1, plus 4, so 5, plus another 2, so 7, 7 x's. And then I have negative 6, take away 4, that's negative 10. So 7x minus 10 over x minus 1 times x minus 2. And that is going to be my answer. Question 19. The curve C has equation y equals 2x squared minus 8x plus 5. Find the coordinates of the turning point on C. So we need to complete the square. You could also get a question that says, write it in the form a times x plus b squared plus c, where a, b, and c are integers. That's the same question. So it's a complete the square question. It's a harder one because we've got 2x squareds. So we need to factorize out the 2 first. So 2 times x squared makes 2x squared. 2 times negative 4x makes negative 8x. And 2 times 2.5 makes 5. Now I'm going to complete the square on this bit. I'm going to leave the 2 on the outside. I'm going to put a big bracket because I'm also going to have another bracket. So there's going to be a bracket in a bracket. I'm going to half the negative 4, which is going to give me negative 2. So it's going to be x minus 2 squared. X minus 2 squared, if I expanded it, would give me an x squared. It would give me a minus 4x. It would also give me a 4, which I don't want. So I'm going to take away the 2 squared. So take away 4. And I've still got this 2.5 on the end. And negative 4 plus 2.5 is negative 1.5. Or negative 3 over 2. And then I'm going to expand back this big bracket. So 2 times x minus 2 squared. So it's 2 times that, and then 2 times that. 2 times x minus 2 squared is just 2 times x minus 2 squared. 2 times minus 1.5 is minus 3. So now it's in the right form. It's in the completed the square form. So how can we find out the turning point? So what is the smallest thing that this could be? The smallest thing I could get from something squared is a 0. So that's when x is 2. When x is 2, this whole part here is going to be worth 0. So what's going to be left when that's worth 0? Y will be negative 3. So the minimum point, the smallest thing I could get out, which is the turning point, to negative 3. Question 20. BAC is a sector of a circle, center at A. So A to C is a radius, and A to B is also a radius. We need to find the area of the shaded segment. So the segment area is the sector area. So the area of the whole shape, the area of this whole shape, take away the triangle area, which is the area of the triangle. So let's do the sector area. Sector area. So it's part of a circle. The whole circle, the area, is pi times the radius squared. But we've only got a fraction of the circle. We've got 52 degrees out of 360 in total. So we've got 52 360ths of the whole area. So 52 360ths of pi times the radius squared. 104 over 5 pi, or 65.3. Save it in the calculator. 65.345 centimeters squared. The triangle area is half AB sine C. The area of a triangle is half AB sine C. So it's half times 12 times 12 sine 52. Half times 12 times 12 sine 52 is 56.737. 56.737 centimeters squared. So the area of the segment is 65.345, take away 56.737. So it's the one I saved as A, take away my last answer, 8.61. 8.61 centimeters squared. Question 21. A, B, C, and D are points on the circumference of a circle. DE is a tangent to D, to the circle, a tangent at D to the circle. BC is parallel to DE. Angle CDE is 61, so all that information is on the diagram. Work out the size of angle BAC. B to A to C. Write down any circle theorems that you use. So firstly, not a circle theorem, but alternate angles are equal. I'll write it down. In another question, it could say, give a reason for each stage of your working. So these Z angles are alternate angles. Alternate angles are equal. I'm going to connect up A and D. So now I've got a cyclic quadrilateral, and the opposite angles in a cyclic quadrilateral add up to 180 degrees. So this whole angle BAD is 180 take away 61, which is 119 degrees, and its opposite angles in a cyclic quadrilateral add to 180 degrees. So that's 119 degrees. So when we have a triangle inside a circle, so we have, let's draw this. So we have a circle and a tangent, and any triangle coming from that tangent, from that same point, we have the alternate segment theorem. So this angle and this angle are equal, and the same on the other side. This angle and this angle are equal. So we've got that here. We've got a tangent and we've got a triangle. So we have the alternate segment theorem. So DAC is also 61 degrees because of the alternate segment theorem. So now we can work out BAC because it's 119, take away 61. 119 take away 61, and that is 58 degrees. Question 22. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of the sequence. So the nth term of a quadratic sequence is going to be in the form an squared plus bn plus c. And we can tell it's a quadratic sequence because the second difference will be the same. So the first difference, so we can see it goes down 4, down 6, down 8, down 10. The second difference, the difference between the differences, is minus 2 each time. So the second difference is the same. We know it's a quadratic sequence, and the second difference is always 2a. So if 2a is equal to negative 2, a is negative 1, which means it's negative 1n squared plus bn plus c. The difference between the first and second terms is always 3a plus b. So if 3a's plus b is negative 4, a is negative 1, so 3 negative 1's plus b equal negative 4. Negative 3 plus b is negative 4. B must be negative 1. And the first term is always a plus b plus c. So a plus b plus c is 19. A is negative 1. B is negative 1. Negative 1, take away 1, plus c is 19. C has to be 21. So our sequence has the nth term minus 1n squared minus 1n plus 21. And we can check using the calculator. So the fifth term should be negative 9. So when n is 5, we should get negative 9. So negative 5. So take away 5 squared, take away 5 plus 21, we get negative 9. So in any quadratic sequence, the first term is a plus b plus c. The difference between the first two terms is 3a plus b, and the second difference is 2a. That is because a sequence is an squared plus bn plus c. When n is 1, the first term, if n is 1, we've got a times 1 plus b times 1 plus c. We've just got a plus b plus c. The second term is when n is 2. So a times 2 squared gives us 4a. B times 2 gives us 2b and plus a c. The third term is when n is 3. So a times 3 squared is 9a. B times 3 is 3b. And we've got the plus c. So the difference between the first and second terms, what do you have to add on to a plus b plus c to get 4a plus 2b plus c? That's 3a's and a b. What do you have to add on to 4a plus 2b plus c to get 9a plus 3b plus c? That's 5a's plus a b. And what's the difference between 3a plus b and 5a plus b? That's 2a. So in any quadratic sequence, the first term is a plus b plus c. The difference between the first two terms is 3a plus b, and the second difference is always 2a. Question 23. There are only 2 red counters and n blue counters in a bag. Sabrina takes 2 counters at random from the bag. Find an expression in terms of n for the probability that both counters are red. So we've got 2 red, n blue. So we've got 2 plus n, or n plus 2 in total. So what's the chance of the first counter being red? We've got 2 red out of n plus 2 in total. The second one being red. If we take a red, there's only 1 red left, and there's 1 less, so n plus 1 in total. So the probability of both being red is 2 over n plus 2 times 1 over n plus 1. So 2 over n plus 2 times n plus 1. And that is the answer. Question 24. The diagram shows a right-angled triangle ABC. A to B is 11 to the nearest centimetre. So we've got a bounds question here. B to C is 7.5 to 1 decimal place. Calculate the lower bound for the angle X. So if we've got 11 to the nearest centimetre, it must be between 10.5 and 11.5. 7.5 to 1 decimal place is between 7.45 and 7.55. So we've got the hypotenuse and the adjacent. So we're looking at cos. So cos x. So the upper bound for cos x is going to be the biggest adjacent divided by the smallest hypotenuse. And the lower bound for cos x will be the smallest adjacent divided by the biggest hypotenuse. And it's actually the upper bound for cos x that's going to give us the lower bound for the angle, because the cos graph is shaped like this. So this is 90 degrees here. So as cos, this is cos x, and this is the angle. So the bigger cos x is, if cos x is bigger, it gives us a smaller angle than if cos x is smaller, in the range 0 to 90 degrees. So it's actually the biggest cos x is going to give us the smallest angle. So shift cos 7.55 over 10.5 is 44.02. So the lower bound for x is 44.02. And you can check that because you can see if you did put it in the other way around, you would get a bigger answer. The lower bound is the 44.02 degrees. And question 25, L is the straight line equation y equals 2x minus 1. C is the graph of equation y squared equals 10x squared minus 11x minus 2. Using algebra, find the coordinates of the points of intersection of L and C. You must show your working. So whenever we have points of intersection of 2 graphs, we have simultaneous equations. So we have to solve these 2 simultaneous equations. We have to solve them using substitution. And in this case, we want to square both sides of our straight line graph, make it y squared equals 2x minus 1 squared. and then we can substitute in for y squared 2x minus 1 squared. So we get 2x minus 1 squared equals 10x squared minus 11x minus 2. So we've got something just in terms of x, and we will solve it. So expand the brackets, make it equal to 0, and solve the quadratic. So 2x minus 1 times 2x minus 1. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x again. And negative 1 times negative 1 is a positive 1. Now we want to make it equal to 0. We are going to get rid of the smallest x squared, which is the 4x squared. So take 4x squared away from both sides. 10x squareds take away 4x squareds are 6x squareds. We want to plus these two negative 2x's. So plus 4x to both sides. Negative 11 plus 4 is negative 7. And take away 1 from both sides. Negative 2 take away 1 is negative 3. Now we want to solve this quadratic. We've got a choice. We could use the quadratic formula with a as 6, b as negative 7, c as negative 3. Or we could factorize this. If we do the a times the c, 6 negative 3's and negative 18. What multiplies to give a negative 18 and adds to give a negative 7, that would be 2 and 9, and it will be plus 2 and negative 9. So I'm going to rewrite negative 7x as plus 2x, take away 9x. Then I'm going to put it into brackets. So what can I take out of my first two terms? 6x squared and 2x. They've both got a 2 in them and an x. So 2x is my first term. 2x times something makes 6x squared. That's 3x. 2x times 3x is 6x squared. 2x times something is 2x. That's 1. Something times 3x makes negative 9x. That's negative 3. And negative 3 times positive 1 is negative 3. So x, what makes the first bracket 0? That's 1.5. What makes the second bracket 0? Minus a third. So x is 3 over 2, or x is minus a third. And y is equal to 2x's take away 1. So 2 3 over 2's take away 1, or 2 minus a third's take away 1. So 2 1.5's take away 1 is 2. And 2 minus a third's take away 1 is minus 5 thirds. So we have, as our answer, x is 3 over 2, y is 2, or x is minus a third, and y is minus 5 thirds.